Video we're going to go through the exam technique for answering buffers questions relating to how buffers are made and how they work. So if we start off by thinking about buffers in general terms, we've got a weak acid which dissociates to give us conjugate base and H+ ions, and that would be our buffer equation. So let's start off with what a buffer is. So for that you're going to need to learn your definition. The definition says a buffer is a system that minimises changes in pH, and for that you will get 1 mark. The definition says on the addition of small amounts of acid or alkali. Quite often you'll find, as I've done here, the word small is in bold in the mark scheme, which means you have to say it. Buffers are only designed to cope with small amounts of acid or alkali, otherwise they become overloaded and they don't work. So quite often you'll get 2 marks for this definition. So that will be the first part of your exam technique. Once you've explained what a buffer is, you're then going to go on to how it's made. So key points in this: you need to talk about partial neutralisation. You need to mention that the acid is in excess, and you need to give an equation for the formation. So for example, if I was to take this acid up here, so my acid is HA, I'll pick a base, an alkali to react it with. So if I go for sodium hydroxide, I'm going to get a salt formed from the negative ion and the metal, and I'm going to get some water. To make the buffer, so if you look at the buffer, I need lots of acid, lots of its conjugate base, and some H+. So if I take this acid here, if I was to neutralise all of it, then I'd have no acid in my buffer, so this must be an excess and I must only neutralise part of it. So that will be the second bit, and I'm probably going to get 2 marks, 1 for the explanation and 1 for the equation. And I'm going to explain what the buffer equation is, which we've got at the top of this page. Then I'm going to say what happens if you add acid, and for that I'll need an equation, and I need to talk about which way the equilibrium shifts. And then I'm going to talk about what happens if you add alkali, and again I'll need an equation, and I'll need to say what happens to the equilibrium. And each one of these things will be 2 marks, so 1 for the equation and 1 for the shift in equilibrium. So next we're going to look at some examples where you can practice using this exam technique to answer questions. Now we're going to do some practice with using the exam technique to answer buffers questions. So we're going to look at this question. It says buffers are used in living systems to regulate biochemical processes. I've left this the same as something I've said in another example, because really this opening sentence is only there to tell me that I'm answering a question about buffers. Importantly, it says explain what's meant by a buffer system and describe how a buffer system based on methanoic acid can act as a buffer. So we're going to look at answering this. If you want to pause the video and have a go at it, I'll tell you that it's worth 7. So pause now. So the first thing we're going to do is write our definition. I'll get 2 marks for this definition. 1 is for saying a buffer is a system that minimises changes in pH, so that bit will be 1 mark. And then on the addition of small amounts of acid or alkali, once again please do say small there, and that will be 2. Okay, if I'm strictly following that exam technique that we discussed earlier, then I would talk about how this buffer is made, but if I look at this question, it's not actually asked how it's made, so I'm going to leave that out now and go on to how it works. So I'm going to start off by writing my buffer equation. Okay, key thing is read the question and look at the acid that you're using. So in this case it's methanoic acid, which is that. I'll leave space my arrows because I can't do them with the keyboard. And that's going to give me the methanoate ion and some H plus ions. Remembering that your buffer does need to have reversible arrows, like so. So that will be third mark. Then I'm going to explain how it works. If I add some acid, what I'm actually adding is H plus ions. Look at your buffer equation. If you increase the concentration of H plus, it's an equilibrium. It's going to want to oppose the change. It's going to try and decrease the concentration of H plus by moving left. So therefore the H plus will need to react with the methanoate ion, so forming methanoic acid, which means that equilibrium has shifted to the left. Next, if I add alkali, what I'm actually adding is OH minus ions. Again, look to your buffer equation. OH minus ions are going to want to react with H plus, forming water. And then I need to think about the equilibrium again. So in this case, if I'm decreasing the concentration of H plus because I'm reacting them with OH minus ions, then this equilibrium is going to want to restore that concentration, so it's going to move to the right. You wouldn't need the explanation, you just need to say which way it shifts. Let's run through those marks. You'll get one for each of the equations and one for saying which way the equilibrium shifts in each case, which gives us our 7. A typical buffers question. This question is about how a buffer system works. If you want to pause the video and have a go at this question, I'm going to tell you that the total for this question will be 7 marks. See if you can get all 7 of them. Pause the video now. Okay, first thing we're going to do then is to deal with this sentence here. Okay, so we're starting off with an introductory sentence that says buffers are used in living systems to regulate biochemical processes. You'll usually find an introductory sentence that doesn't really have much to do with the question. Explain what is meant by a buffer system. That's asking for the definition of a buffer. So I'm going to write buffer is a system that minimises changes in pH. For that we'll get 1 mark. And then we've got to say on the addition of small amounts of acid or alkali, and that will be a 2nd mark. Very, very important that you do say small amounts of acid or alkali, because a buffer system is not designed to take lots and lots of acid and alkali. It's only meant to be for tiny portions to keep the pH the same. So we've dealt with that first sentence there, and we've got 2 marks. Then we're going to look at the second part of the question that we need to deal with here, which says describe how a buffer system based on ethanoic acid can act as a buffer. So we've all looked at questions like this before. I'm going to start off with writing the buffer equation. So I've got ethanoic acid just put those reversible arrows in there. You must make sure that they are reversible. So we've got ethanoic acid turning into the ethanoate ion and H+. Remember, this question has not asked us how this buffer is made, so all we're doing is answering how it works. So once we've done that, and we'll get 1 mark for that. So now we're on 3 out of 7. So I'm going to talk about how it actually works. So if we add acid, so what we're actually adding is H+. And then if you think to yourself, what does H+ react with? So look at your buffer equation. H+ is here, it's going to react with the ethanoate ion. So and if those two things react together, then we're going to get, apologies, still going to get ethanoic acid forming. Next thing we need to say is which way equilibrium shifts. So if we're making more of this, then that means that equilibrium shifts left. And for each of those things we're going to get 1 mark. So 1 for the equation and 1 for which way the equilibrium shifting. Dealt with the acid. Now we're going to say what happens when we add alkali. So if you're adding alkali, what you're actually adding is the OH minus ions. Look again at your buffer equation up here. OH minus will react with H+. Forming water. Again, look at your equation. If we're decreasing the concentration of H+ ions, then this equilibrium is naturally going to want to restore them, so equilibrium will shift right. And again, marking points, 1 for the equation, 1 for the equilibrium. So there we've got 1, 2, 3, 4, 5 for the explanation of how it works, 2 for the equation, giving us our total of 7. In this question we're going to look again at making buffers and how they work. So, opening sentence tells us that this question is about buffers, so we know that that's what we're looking at. Once again, we've got to explain what is meant by a buffer system. 2 marks for that definition. Remember, roughly 10% of your paper will be definitions. Then we've got how you'd make a buffer system and how this can act as a buffer. Total for this question I'm going to say is going to be 9. Pause the video now if you want to have a go at it and then watch the answer. So the answer, we're going to start off by giving our definition of what a buffer is again. Definition, a buffer is a system that minimises changes in pH for the first mark. After that definition then, on the addition of small amounts of acid or alkali. Once again, please do make sure that you say small amounts because that is required usually in a mark scheme. Because buffers only will work if you add small amounts of acid or alkali, otherwise they become overloaded and they no longer work. So that's the first bit dealt with. Then we're going to describe how you could make a buffer system based on butanoic acid. So let's look at that next. So a buffer is made by partially neutralising weak acid, which in this case is going to be butanoic acid. Make sure you're being specific in your question, that's what you've been told to use. Meaning that the acid is in excess. Okay, so we should get 1 mark for the explanation here. We need to make sure that we do say that the acid is in excess, and we should also mention partially neutralising it. Once we've done that, we're going to write an equation for that happening. So if I start with butanoic acid, so make sure, first thing is, really make sure that you're using the correct acid in question. So many people are so used to practicing with ethanoic acid that they don't actually use the one that's been spoken about in the question. I can use any base I want to neutralise this. I'm going to choose sodium hydroxide. And I will get sodium butanoate which is that, and some water. So that will be the equation for making the buffer, and I'll get 1 mark for that. Then I'm going to talk about how the buffer works. Okay, so the first thing I'm going to do is include an equation for the buffer. So remember, look back up at this equation for making it. Any metal ions you use from your alkali take no part in the buffer, so you leave them out. And what you should be left with is an equation that matches what you would write if you were asked to just write a dissociation equation for the acid. And of course I'm going to need to put in reversible arrows in this one. So there's my buffer equation, and I should get 1 mark for that. Next I'm going to explain what happens if I add acid to it. So if I'm adding an acid, then what I'm really adding is H plus ions. Okay, so look at your buffer equation. If you're adding more H plus ions, so you're increasing the concentration of a product, then this equilibrium is going to want to minimise the concentration of that and take it away, so it's going to shift left. So it's going to react with the ethanoate ion, the butanoate ion. And it's going to make butanoic acid. As we just said, that means that equilibrium shifts left. Just go over that again. If you add extra H plus, this equilibrium is going to want to remove those extra H plus, and it's going to do that by shifting left. Marks we'll get 1 for the equation and 1 for explaining what's happening to the equilibrium. Next we're going to talk about what happens if we add alkali. So if we're adding alkali, then what we're really adding is OH minus ions. Again, look at your buffer equation. OH minus ions are going to want to react with H plus ions here. If that happens, then they're going to form water. So if you think again about equilibrium, if we are decreasing the concentration of H plus because they're reacting to make water, this equilibrium is going to want to restore that concentration of H plus, so it's going to shift right. There are final marks. Again, 1 for that equation and 1 for what happens to equilibrium. And that should be 1, 2, 3, 4, 5, 6, 7, 8, 9 marks in total. In this example, we've got something slightly more tricky because we've got benzoic acid. It says the same thing, so it says identify a chemical that could be added to benzoic acid to make a buffer solution. So this is talking about making a buffer solution, which we should recognise from our earlier questions, and then explain how this solution can act as a buffer. So this question hasn't asked us for our definition. It wouldn't matter if you put it in there, just to follow your exam technique, but I'm going to leave it out for now. So I'm going to start off with a chemical that could be added. Well, if you look at this, even though it looks slightly confusing, at the end of the day, this is a carboxylic acid. And if you remember, we make a buffer by partially neutralising a weak acid with a base or an alkali. So we're going to add sodium hydroxide to make the buffer solution. So we've correctly identified an alkali, so we're going to get 1 mark for that. Then it says explain how this solution can act as a buffer, so we're going to put the buffer equation. Okay, you might think this is tricky. That's because you simply have to draw this out. So whereas in the past we got equations that we could write, in this question the only difference is that we're going to draw it. So here is the benzoic acid, and it's going to dissociate. Remember, from your carboxylic acid, that's the acidic proton, so we're going to be left with this negative ion and H plus over here. So that's the buffer equation, we'll get 1 mark for that. And then we need to say what happens when we add acid. So if we're adding acid, then we're adding H plus ions. If we're increasing the concentration of H plus ions, this equilibrium is going to want to shift left to oppose that change. So the H plus is going to react with that negative ion, forming that. We'll get 1 mark for the equation, and we say equilibrium shifts left for another mark. Then we're going to add some alkali. So there's our OH minus ions. OH minus is going to react with H plus. You'll notice that this is always the same, making water. So 1 mark for that. And then we say that equilibrium shifts to the right. 1 mark for that, because if we're taking away the H plus by reacting it with the OH minus, this equilibrium is going to want to restore that concentration, so it's going to shift right. Again, 1, 2, 3, 4, 5, 6 marks in total.